Good afternoon, fellow colleagues. I'd like to introduce to you the report of an article titled The Development of an Application for Microparticle Counting Using a Neural Network. The reporter is Andrii Ryazantsev from Volodymyr Dahl, East Ukrainian National University, Severodonetsk, Ukraine. So, our motivation lies next. The development of the machine vision system with artificial intellect that is an urgent task and will provide the development of all areas of science, technology, and commerce using optical images. The important problem is to provide high accuracy of the microparticle counting. 3 processes are occurred with particles in the experiment: guiding, fixing, and flicking. Incorrect recognition of the process leads to an incorrect counting of the number of particles. So, the task should be solved by the more efficient way in the process recognition. That is, intelligent systems are known for. So, the problem is next. Automatic recognition of the process in which microparticle is involved by the methods of artificial intelligence. Our research goals are to present the machine vision system, to show the preliminary image analysis and criteria of its quality, to represent the development program application for the automatic registration of microparticle moving, to show the reason and perspective for employment the artificial intelligence methods in the next program development. Common view of the machine vision system for optical research realization. Machine vision system consists of the optical primary and secondary sources, optical elements, camera, computer, software, and the protocol suite, with feedback from protocol suite to any necessary part of the machine vision system. Image quality and processing. The quality of images can differ and depends on several conditions, such as illumination, resolution, etc. So one frame from the video file demonstrated a part from a laser setup with chamber at different initial conditions ready for microparticles guiding recorded by CCD camera. Every frame goes through quantization process as described on the slide. Maxima is 255 and the step is 1. For instances such as on the image B, where quantization level did not count any value, it was assigned a value equal to the average between the adjacent levels. Video file is dissected into frames, where significant area is selected. After that, defining of the image quality criteria is held. Criteria are signal noise to ratio, which is the Rose criteria, and contrast ratio, which is relay criteria. If quality is high enough, image segmentation and object tracking are held next. If quality is low, the recording is stopped by software. Statistical image analysis. Variation curves of the experimental images mentioned before and presented again, each image under its variation curve. Curves are marked by dotted and solid black lines correspondingly. Statistical parameters for each experimental image are put in the table below. It is visible that there is a significant difference in mean values of the curves. It means that there is no overlap between curves, and it is safe to process both images simultaneously. Program application for the registration of particle movement. The developed program application is represented main stage of the frame processing and counting of the moving particles. The aforge.net library was selected for the representation of the task, which has already made implementation of motion detection algorithm. A convenient interface was developed for particle movement registrations. It includes such icons as file list, download file, particle size in pixels, algorithm, which you can choose from comparison with the previous frame, background modeling, comparison with the first frame. There is also an option of noise reduction and clearing the captured area. Also, there is a number of counted particles, which now equals to 0. There is also a function of stopping record, if quality is low and particle defining is not possible. The area where microparticle movement is observed is highlighted by the red rectangles. To capture, define, and count such movements is the main purpose of the developed application. There are three processes that are of interest to us: guiding, fixing, and flicking. These processes that occur with particles and need to be defined one from another. It is demonstrated on the slide by line on consecutive frames for each process. The inspiration for solution is article by Bo Yu titled Design and Implementation of Behavior Recognition System Based on Convolutional Neural Network. This article discusses the problem of human behavior recognition in attempt of defining whether a person is standing, running, jogging, or etc. The resulting formula is next, which is presented on the slide, where x is input, value of ith set of three images, y is the output function, y to the power of I is the estimation of y value. The function y to the power of I of the logistic regression model measures how close to the result of the entire training set with parameters omega and b is to y to the power of I. Conclusions. The paper is focused on the development of program application for the automatic registration of a microparticle movement. For convenience, image processing is based on the information model, which consists of two stages. The preliminary one is used for the basic image characteristics, such as signal-to-noise ratio, contrast ratio, resolution of the system, and statistical analysis for making a decision whether the image is good enough for the next consideration. The main stage includes the segmentation of the picture, background modeling, noise reduction, and observation of a particle's movement. Very important problem in microparticle counting is proper counting of the objects. Three processes are occurred with particles in the experiment: guiding, fixing, and flicking. Incorrect recognition of the process leads to an incorrect counting of the number of particles. They might be skipped or counted twice. In the paper, there is stated problem of automatic recognition of the process in which microparticle is involved by the methods of artificial intelligence. The task of the process recognition is formalized, and the method of deep learning system is discussed. In the future, it is planned to continue the development of neural network for making decision, which provides recognition of the process and right counting for the microparticles in the machine vision system. Thank you for your attention.